Hello, everyone, and welcome to this latest webinar from Omdia, brought to you by Informatech. My name is Alan Tatara, Senior Event Manager for the Omdia webinar team, and I want to thank everyone for joining us. Today, we'll discuss how to survive the encrypted network traffic apocalypse. So our panel will explore how you can ensure successful decryption and continued traffic visibility, all while mitigating the risk of potential threats lurking in encrypted traffic flows. Our webinar is co-presented by Omdia and our partners Enea Qosmos, F5 Networks, and Juniper Networks. All right, so before we continue, let me just highlight some of the features available for you on our webinar. So the console that you're looking at, it is completely customizable. So this means you can open, close, move, or resize any of the windows and arrange the console to your preference. Now, at the bottom of your console, there are a number of application widgets. And I want to make sure that you check out the resource list widget, because this is where you're going to find the downloadable slide deck from our session today, as well as other valuable information, including a special report authored by analyst Eric Parizeau. You can also join in on the conversation via Twitter. Just make sure you follow us using the hashtag Encryption. We will have a live Q&A session directly after our presentation, so please remember to submit your questions or comments at any time by using that Q&A window that you see on the left side of your screen. This webinar is being recorded, and we will send out the on-demand version to you within about 24 hours. And finally, if you experience any technical issues, just click on that question mark widget, and you will get the answers that you need. All right, so let me take this opportunity to introduce to you our panel. First leading our discussion is Eric Parizeau. Eric is a principal analyst in the Cybersecurity Operations Intelligence Service segment at Omdia. Eric is joined by Jean-Baptiste Duvachel. JB is a senior technical account manager at Enea Qosmos. We are also joined by Don Lauerson. Don is senior product manager of encryption, global certifications, and privacy at F5 Networks. And rounding out our panel, we have Mike Spanbauer. Mike is a security technology evangelist at Juniper Networks. So welcome to our panel. It is great to have you with us today. So Eric, let's get things started. I will now turn it over to you.
All right, Alan, thank you so much. And thank you to everyone joining us live or on demand today. Enterprise network visibility is one of the most important challenges in enterprise security today. And while network encryption is one of the most important safeguards we have for our businesses, governments, and even our freedoms, because of the evolution of encryption, security and visibility can actually be at odds in some interesting ways. So I'm excited to have this conversation with you today. But before we begin, again, a special thanks to our partners, Enea, F5, and Juniper Networks, for being part of the conversation today. Now, it's going to be a fast-paced discussion. We're going to cover a lot of ground, but I think you'll enjoy it. So I'm sure at least a few of you saw the title of this webinar and asked yourselves, I know encrypted network traffic is complicated, but is it really an apocalypse? That seems very strong. Well, we'll get to that in a minute, but I wanted to highlight some numbers as part of my research on encrypted network traffic in context with overall internet traffic. And we're not going to do a deep dive here, but you can see the numbers. In just 15 years, the overall volume of traffic on the internet increased 10,000%. It's a number so big that it's hard for our brains to even process. It's amazing. Most recently, though, we've seen a pretty big flip on the encrypted traffic side. Just a few years ago, the majority of traffic was not being encrypted, to now where the vast majority of the traffic arriving at the enterprise network perimeter now is encrypted. Now, Don Lauerson from F5 will talk more about this in a minute, but the biggest drivers of that change, one, Google making SSL a factor in website reputation analysis and search engine optimization algorithms, and two is just Netflix. When Netflix encrypted its traffic 5 years ago, 2/3 of the network traffic in North America became encrypted almost overnight. And as I said earlier, encryption is critical for maintaining integrity and confidentiality of data of all kinds, business and personal. But when network traffic is encrypted, visibility into that traffic is severely limited. Our panel today will talk about some of the ways you can work around that, but in Omdia's opinion, the only way today to be 100% sure that encrypted traffic is not malicious is still to decrypt and inspect it. Now, most organizations do not do that today. Our research shows that 1 in 10 enterprises decrypts and inspects encrypted inbound traffic. Why not? Why not more? It's complicated, it's expensive, it can be a network performance challenge, and typically it involves a heavy on-prem appliance deployment that many enterprises are trying to get away from, frankly. And the evolution of encryption protocols is only adding to that challenge, as we'll discuss. Now, unfortunately, your adversaries are aware of all these things, and as a result, they've been taking advantage of encryption for years. The headlines here on the screen from our teammates over at darkreading.com show just a sampling of the various ways attackers use and abuse encryption. Most often, it's using encryption to cloak malware on the way into the enterprise and avoid perimeter defenses, and then using encryption again once it's time to exfiltrate data so you cannot see and don't realize what's leaving your organization in an incident. Now, any one incident like that is not an apocalypse for the world, but it may be an apocalypse for your organization if it happens to you. We've seen it happen too many times, and that's not where you want to be. And that's why it's important to understand the changing landscape around network visibility. We're going to get a lot into this as we go along, a lot of detail, but let's begin by digging into the importance of network traffic visibility. Now, I've researched both security infrastructure and operations like issues like threat detection and response for quite some time. And in both areas, I can confidently say that the absolute foundation of just about everything you do as a practitioner is going to be network security visibility. Now, I've said it many times, but it's very difficult, if not impossible, to identify what you cannot see. I love this freight container imagery here because it illustrates the obfuscation problem perfectly. It's like an encrypted packet. The contents of each container here could be dramatically different, but you don't know for sure until you take a look inside. To be able to see and stop a cyber attack, you have to know what's happening on your network. And to do that, an organization must be able to monitor, capture, identify, and analyze network traffic flows into, across, and usually also out of its network environment. Network traffic encryption, for all its benefits, represents a fundamental barrier to successful enterprise network visibility. Encryption obfuscates the ability to identify and analyze the packets within network traffic flows, including deep packet inspection. Without this analysis, enterprise network security teams are unable to discern the content within each flow. So if your header analysis at the perimeter says something might be anomalous or malicious, you can't see the payload to know for sure. So what do? Additionally, many other security controls that rely on effective network visibility are rendered useless by network traffic encryption. So with that, let me introduce the first of our panelists. I am so pleased to have him with us today, someone I've known for many years and one of the industry's most distinguished authorities on enterprise network security. Mike Spanbauer is technology evangelist with Juniper Networks, and he's going to talk a bit about the intersection of security and privacy. Mike, please take it away.
Thank you, Eric, and welcome everyone. So encryption is certainly a challenge, as Eric's well alluded to, and his research as well as others, support the efficacy that actors are seeing using it in their attacks, in their approaches to really get inside of enterprise organizations the world around. Right, so we're at odds with being able to support those privacy needs that individuals certainly have and as businesses require, as well as then on the other side as practitioners to fight the actors. And this challenge, this contention, it's this prospect that I've heard described as security versus privacy. But customers shouldn't have to choose. And part of what we're going to share today is some approaches, some ideas, and I think really industry enlightenment around innovative ways to address this. And really at its root, the challenge that we face here is that encryption, it's not just an attack mechanism. It is, as Eric noted, an obfuscation approach or an evasion tactic. And really, once you find a single evasion approach, you can bypass many controls, and this is what we've witnessed over the last 5 to 8 years. As actors increasingly using more and more advanced encryption, ciphers and approaches and attacks in their own development efforts. So, at its root, why does it work? Why are they using it? I mean, in general, malware families use old ciphers, and to that point, right, count order in that are potential indicators for us in the industry to use, and we'll talk about that in a little bit. But also dates on cert, code reuse, and really, the fact is that there's an awful lot of unpatched systems and ciphers that should have been deprecated or no longer been in use are still employed. So really, we have to be mindful as practitioners in the industry. And a quote in particular that our Threat Labs leader here at Juniper said, Munir Hahad, cybersecurity is a race that has no finish line, right? It is constant diligence and monitoring of the techniques in use, both throughout the industry and against your organization that you need to ensure your systems, your technology, and your capabilities address. And so with that, I'll turn the session over to my fellow panelist, Don Larson. Don, you want to take it away?
I will. Thank you, Mike. Welcome, everyone. So I like to start with this slide. It sort of echoes what you've already heard today, but I view it as really a perfect storm. And for many of our customers, it's a forcing function to really reevaluate how they design their environments, how they design, the idea of zero trust, right? The idea of a perimeter. But the problem is that with this increase in encryption, and maybe just even a little bit of history, right? I think many folks probably recall, we used to have 1K keys, right? And when people upgraded to 2K keys, they actually found that their boxes, their internal boxes, the hardware was not able to keep up with the demand. So then you take all of these factors, such as the increase in data privacy, GDPR, as was mentioned, CCPA, Google search results rankings, all of these have driven to a forcing function that we see as a great opportunity. And from an apocalypse perspective, it is, in fact, disruptive to these environments and to the ability to protect those assets within the organization. And as was mentioned, and let me sort of give a visual here, right, of exactly what is happening is, as was mentioned, the bad actors today know, right, what security products are in most environments. And none of those were purchased, or at least very few of those were purchased all at the same time. They've been purchased over time. And that means that they're going to have different sets of features and supportability for those ciphers, right? Before, everything was RSA, right? RSA for the certificate, RSA for the ciphers. But now with a lot of what you saw out of the Edward Snowden, the Heartbleed, you've seen, and really what ultimately resulted in TLS 1.3 is you've seen a change in that cipher mix, right? The AES GCM mode. You've seen a lot of the crypto primitives being updated, and many of those legacy products did not support, or if they did support those, they took a performance hit. So really here is a visual of just showing exactly what's happening, right? Is the bad actors know what is inside the environments, typically. They can guess, and they can build that attack around creating this blind spot. And what that means is that the traffic, rather than going through those products that you have all bought and have paid money for to do specific functions, are no longer able to do that. It's being bypassed, in some cases unknowingly, for some folks, until they've actually dug into what is going on. And as was, Eric's initial example, right, is you don't know what's in those packets, and oftentimes it is fine, but it can hold very damaging payloads that can ultimately impact the company's reputation and IP. So this is the classic method, right? So what we've seen over time is the products now that can support the newer ciphers do that, but then you have this explosion of complexity, right? Because every single box needs to be able to encrypt, decrypt, And then you think about the key support, the certificates that have to be on every single one of those boxes. So now you have this explosion around operational efficiency. You know, how do you manage those keys? How do you troubleshoot a product or one of those services that are in that chain to know and do it quickly, right? And that's really where we're at today. And we'll talk a little bit later in today's session on how we think we can simplify that. But this is what we see in most environments today that have evolved and have tried to address this problem sort of in a step-by-step process. And with that, I will turn it over to JP.
Thank you, Don, and welcome to everyone. As we have just seen, encryption is used to hide threats, making decryption and DPI a permanent necessity. But it would probably help those of you joining us if we take a moment to define what we mean by DPI. We decrypt to inspect the payload content, like the body of an email or an image. This payload inspection is what we are referring to today when we talk about DPI. But the term DPI is used by many for all traffic inspection and classification. That's probably the case for some of you, and it's the reason why we still refer to our product as a DPI engine, even though in the majority of deployments, the traffic is never decrypted. So traffic classification is really a more fitting term for full L2 to L7 inspection. But whatever label you use, it's a critical building block for all networking and security solutions. So now let's look at how cybersecurity applications use traffic classification on encrypted flows. Using DLP as an example, the classification engine is embedded to, one, gather important application visibility, and two, enable decryption to be used very selectively. Let's start at the bottom. The encrypted traffic flowing by is initially run through a first packet processor. Whether a flow is encrypted or not, first packet processing can be used to identify an application or service, like a connection to Office 365. At this point, depending on the application, you can go ahead and apply rules, like letting the traffic pass without further analysis. As an example, with an IPsec tunnel, there's no advanced processing needed. You can accept or just deny it from the first packet. If you need to analyze the flow further, then you apply full encrypted traffic classification based on the analysis of multiple packets. For example, this is where you can detect SharePoint or Microsoft Teams over Office 365. Certain higher level security rules can be applied at this stage without decrypting traffic. For example, a rule based on entropy on DNS request. But if your DLP application needs more granular information, like checking for highly classified material, then you can decrypt the flow and run DPI. So as you can see, the classification engine gives you the visibility needed to detect possible threats while using decryption and DPI on selective flows only. So now, how do we classify flows today? Well, we use a lot of different techniques that make use of the data that remains clear, even in encrypted flows. For example, from the very first packet, we can use known IP addresses or ports or even correlation with DNS traffic to identify the service provider. Google services and the most popular SaaS application can easily be detected using one of those techniques. For the full ETC, we can classify a flow based on the domain name from the SSL certificate or the DNS request. Such information provides more granularity and allows detection of sub-services. For those complex applications with proprietary encryption, such as Skype or the peer-to-peer protocols, we can look for binary patterns or just analyze the behavior of the flows. This all works very well today, but there are changes on the horizon that will impact these visibility strategies. So now I'm passing over to Eric.
All right, thank you, JB. And we'll get into those changes in a minute. But specifically, I want to provide some background first and talk about some of the architectural changes that are versus what's being done today that are affecting network visibility. So as I said, my fellow panelists are going to do a deep dive on architecture specifics shortly, but what I really want you to understand here today is that the changes in the encryption landscape are going to require changes in visibility architectures, and that's going to happen in the near term. So a little background, there are two traditional methods to decrypting inbound enterprise network traffic. There's the tap span or passive method in which network traffic flows are duplicated. The original flows continue on to its destination in most cases, and the duplicate stream is decrypted and inspected by any number of security systems, or it's just streamed to disk and decrypted later or as needed. That worked fine until TLS 1.3. That's the newest and most secure set of cryptographic protocols approved by the IETF in 2018. It's really hard to explain without getting super technical, but in short, TLS 1.3 requires use of a unique session key exchange technique called Diffie-Hellman ephemeral. With DHE, a new session key is created each time a new network session is initiated. This significantly increases the complexity involved with network traffic decryption, so much so that passive decryption is not going to be an option, at least not without significant changes to an organization's decryption architecture. And then there's the proxy-based method or the active method. This relies on an inline device, a proxy in some form, that is located in between a client-server connection. That proxy impersonates the server to the client and the client to the server. And by doing so, can obtain the recipient's private key and then allow you to decrypt the encrypted traffic. Now, because this happens essentially in real time, the changes in TLS 1.3 are less of an issue. But to perform real-time decryption, the ever-increasing volume of encrypted inbound traffic that we talked about is an issue because it's expensive because of the compute required, has significant network performance implications as well, especially for organizations that are moving more and more to the cloud. Most organizations are undergoing digital transformation in large part to avoid IT bottlenecks like hairpinning cloud traffic back to the data center. And yet decryption still often requires that. So again, the key theme is that the architectural approaches to gain visibility into encrypted traffic through decryption are becoming less and less viable. And now is the time to think about making some of those changes. So with that in mind, let me hand the baton back to JB Duvachel from Enea, who is going to advance the discussion on these visibility changes. JB, back over to you.
Thank you, Eric. And so, Eric, you're right. The TLS 1.3 encryption standard is an important change, along with the new version of the decrypt protocol. Under both, some data that was previously available in clear are now encrypted. DNS exchanges will be soon encrypted as well. This means there will be very limited data left for analytics without decryption. A few metadata from protocol layers and basic flow information, such as the IP address and the port. In addition, the SSL pinning will make it impossible in some circumstances to deploy a proxy server to perform decryption. In some, decryption and payload inspection are going to become more difficult and expensive, and many of the algorithms currently used to classify traffic or perform other analytics like malware detection are going to break. So new strategies here are needed, and Don will now explain the first one.
Yes, thank you. And the end of the day, right, is security and encryption should be invisible. We like to focus on the fact that at the end of the day, people are trying to do their job, they're trying to do their work, and that performance and those fundamentals need to be maintained. And that's really driving a lot of these design decisions and discussions, has been mentioned, right? So imagine all of the different crypto, the different performance, now looking at the redesign. How do you make sure that you're able to support those legacy applications? How do you make sure that you're able to still provide full availability and uptime? And then how do you actually future-proof those designs to anticipate the cloud, to anticipate some of the changes? And was mentioned earlier, right, is the bad actors are always advancing, always thinking up new ways to, take intelligence or the IP out of the organization in a way that needs to be flexible and agile. So the key point here is you need to still maintain the fundamentals, and a lot of that has to do with being able to provide that visibility, but do it in a way that is performant as well as flexible. And this is the example that I wanted to provide. It does, in fact, anticipate the ability to drive that traffic in a way that is intelligently managed. It is based on policy, which, as many folks probably understand, right back to the privacy discussions, you do not want to decrypt sensitive information, right? If you do, then there's certainly a handling obligation there. There may be regulatory obligations there. But being able to drive that traffic now, rather than going through every single device, being able to do it in a way that is intelligent based on, for example, category-based lookup or IP geolocation, right? Maybe you don't want some connection going to Uzbekistan if that is not a part of the business. And then you need to be able to actually protect those keys in a net HSM or in a standards-based way, such as FIPS or common criteria. And that's really what we're going to be talking about here as we move forward. And I will go ahead and show the two directions that you need to anticipate, right? For the first one is the inbound. And we've talked about that. That's really your users connecting to those corporate apps. How do you make sure that that visibility is in place? That's usually where the attack vector is first going to come in. And you want to be able to do that in a way, again, as I mentioned, back to those fundamentals in a performant way, but do it leveraging those security products that you have purchased. And with that, I will hand it back over to JP.
Thank you. So we are going to zoom in now on the steering model that Don just explained, so we can understand the role that traffic classification plays in this architecture. First, you need to determine which flows need to be decrypted and inspected by which functions. Encrypted traffic classification is what enables you to do this. Then you can apply the same single pass architecture to encrypted classification as you can with single pass decryption. This can give you a real performance boost as decryption becomes more expensive. But here, accuracy and granularity matter really a lot. If you can only identify a limited number of applications and your accuracy is not that great for those, then even with the best architecture, you're still going to be doing a lot of unnecessary decryption and even letting some threats slip by undetected. For example, it's not relevant to analyze decrypted content of a Microsoft Teams audio call, while it's important to do so for SharePoint file transfer. The same goes for using a classification engine that performs poorly in general with encrypted traffic and has no strategy for coping with the changes to come, which is what I think we will be discussing next. Mike, passing you the microphone.
Thanks, JB. And I think both yourself and Don, really did a great job of setting up, the architectural shifts and considerations. The piece that I'll add here is that, the architecture choice that each organization makes must provide the ops team and really the practitioners with the managerial or the operational control. So it's one side to have the technology in place to handle the packets and, of course, direct the flows and, decrypt, et cetera. But having that visibility into and control of both the policies as well as the behavior of what those policies do is crucial. And as I think, Don, you shared at the beginning, right, oftentimes, organizations approach their architectures in project-based components, right? It's, acquired over time, pieces are added to, their entire defense in depth. And as a result, there may be gaps in control, visibility, and operational weaknesses. And so, what it comes down to is ensuring that you have the keys and the managerial control to provide your organization with the operational insights and ability to handle the traffic on an as-needed basis. So, Eric, would you do me the honor?
Thank you, Mike. So let's move ahead to a brief discussion of some new ways to gain encrypted traffic visibility. In our research on emerging alternative approaches, Omdia identified 3 primary categories. And due to time, we're only going to touch on each one briefly. But if you're an Omdia subscriber, you have access to my report, Fundamentals of Network Traffic Decryption and Risk Management, where I offer a very deep dive on each of these. First is cloud-based decryption. This is essentially decryption and inspection as a cloud-based application service. It is often a feature of a broader security platform offered by a vendor or a service provider. We generally refer to these as zero trust access or ZTA platforms, but another research firm you might have heard of also calls it SASE. The benefit is that the vendor handles all the messiness of decryption and inspection for you. The biggest downside is that most vendors are pretty limited today to specific types of traffic or specific protocols, such as only HTTPS traffic, for example, or limited to web domains that are unknown or uncertain to be non-malicious. Second approach is called session key forwarding, also referred to as symmetric key interception. SKF uses a probe or agent to copy encryption keys from host memory during the TLS handshake process. This happens in a matter of milliseconds before the encryption key exchange is complete. And just as quickly, those keys can be shared with a separate decryption system before the network session's first packet, encrypted packet, even arrives. It's a brilliantly efficient method that greatly reduces the compute power needed to obtain key pairs, and it's compatible with many existing network and security solutions. But it's the most nascent of the 3 approaches, so its long-term effectiveness still needs to be borne out. And it also requires an agent or microservice on all endpoints. Finally is encrypted traffic inference. ETI involves capturing and analyzing an encrypted network session's flow data attributes, including DNS metadata, TLS handshake information, and HTTP packet headers. By identifying certain patterns related to sequence of packet length and times, or byte distribution, and many others, it has proven possible to identify malicious elements within an encrypted traffic flow with few, if any, false positives, all without ever actually decrypting the traffic. The best way to think of ETI, it's like recreating a puzzle picture, but only using a handful of the puzzle pieces. Now, the potential benefits of ETI are huge in a variety of ways, but particularly for compliance. Decryption often involves the risk of violating user privacy. There's also probably the most controversy with ETI, however, with some vendors positioning it as an alternative to decryption. It's too early to make a call on that according to Omdia, but it definitely has the potential to dramatically reduce the amount of traffic an organization has to encrypt, and that is very significant. Now, I'll virtually pass the microphone back to JB from Enea, who is going to talk more about these emerging alternative approaches, starting with a hybrid approach that I think indicates where future visibility architectures are headed. JB, please go ahead.
Yeah, thank you, Eric. So as you mentioned, one alternative approach is to use the ETI as we do for traffic classification and to perform classification and decryption in the cloud. So here you will recognize the steering model with the single pass traffic classification. It's a model well suited to the cloud, to the SASE architectures, and to the service-based model in 5G deployments. One of the main differences here is that the form factors are changing with a gradual evolution from delivering key functions in the form of black box appliances to containerized microservices. Another key difference is the consistency that single pass classification can bring within the integrated service model used in the cloud. As it is now, we repeat the same action several times with disconnected solutions, with the risk that each action returns something different. For example, one solution labels the flow as YouTube, while the other as Google Video. So now I let Mike giving you more details about the ETI versus TLS.
Thanks, JB. And indeed, when it comes to approaches, as Eric pointed out, there's a number of novel and frankly innovative concepts. And encrypted traffic inference is think of it as, again, as Eric noted, right? Having part of the pieces in order to, in essence, identify the threat or the bad actor activity in this case. So at its root, right, eventually there's some activity, some indicator that can be captured and seen by the system. And so whether that's on this specific session establishment or prior, right, there are indicators that can be captured, right? These include, endpoint behavior, north-south traffic behavior, right, protocols in use, right, destinations. There's a number of attributes that ultimately all kind of become a fingerprint and reveal the actor's intent. And so using all of these in aggregate, you can look for bad behaviors, groups of behaviors, the sequencing, the rest of the metamaterial, and through, aggregation and really, statistics, machine learning, AI, et cetera, other algorithms, you can, with reasonable confidence, achieve a fairly, accurate verdict on, certain actions, certain campaigns, certain threat types, because in general, right, the bulk of threats, universally are not, patient zero or first patient scenarios, right? Campaigns are run, to tens of thousands of hosts. The first couple trigger, these trip lines, and subsequent attacks from that IP are known. So, there's certain activities that you can block as a result. Now, that works really well for 1.2 or prior, right, and being able to see all this material. So what about 1.3? Similarly, these behaviors are still visible prior to session establishment, and in aggregating more of those disparate components, as JB just noted, right, ensuring that you're leveraging the intelligence of all of your assets, all of your capabilities, and correlating that across the environment, through more advanced, machine learning algorithms. And we don't have time to get into them today, but, you could certainly introduce additional data points that ultimately not only achieve a high degree of accuracy when rendering a verdict on a flow or on a particular activity, but it also reduces, FPs or false positives, as well as increases confidence to, reduce false negatives, to a point where you've got the ability to now knock down a lot of traffic that no longer even needs to be inspected or decrypted. And so this is that flexibility and freedom to ensure that the resources are applied to those areas that need to be, and leveraging capabilities like ETI to augment. And it's an and strategy, to be very clear, right? This isn't an or, this isn't an exclusive approach, right? This is in addition to other technologies used. And so with that, JD, I'll turn it back to you.
Yeah, thank you, Mike. So we have discussed some examples of using machine learning for threat detection, and machine learning has an important role to play too in traffic classification. Now that most of the interesting metadata are encrypted and knowing that decryption must be reserved for the key scenarios, we need to identify the traffic with new techniques. And one option is to combine actually different techniques to reach our goals. Since we still have bit of metadata, some ETC functions will remain useful to classify a service or an application. And thanks to the IP address, we can still classify a service provider or a SaaS application. Using the machine learning, we can now profile the traffic and link it with a specific workflow. A file transfer profile is quite different from an audio call or a video stream. So let's see here two examples. First, we can detect potential lateral movement by combining two techniques. The ETC function will help us to classify some flows as SSH, one between the machine A and machine B, the other one between B and C. The machine learning process returns that their traffic profile are both about file transfer, but also that the two flows are the same volume at the same time. So what can we conclude from that? There's a suspicious event, which looks quite familiar with lateral movement, where A is sending information to C using machine B as a pivot. So we can now send this information to an IDS solution. Next, let's see how to categorize unusual traffic patterns and whether they represent a threat or not. On the right side, we can see a spike in traffic which indicates a potential DDoS attack. A simple IP address check shows that the flow is attached to a Google server. Complementary machine learning process returns a video stream profile. So now we can conclude that the flow spike is due to a YouTube connection and is not a DDoS attack, so we are safe here. And on that, I'm giving you back the microphone, Eric.
All right, JB, thanks again. So I want to make sure we provide you with some action items here as your organization begins its journey toward network visibility and potentially looking at some of these alternative solutions. First, make sure you know the objectives of your security program or the purchasing effort that you're leading. Sort of an obvious best practice, hopefully, but the objective ask this question. Is the objective to put the technology in place to actually gain network security visibility, or is this really a compliance-driven effort where you need to validate and report? Your objectives should be a lot more specific, of course, but make sure you know what they are so they can guide your effort. It should be clear by now that I'm a huge believer in the importance of network visibility. In my view, it's hard to see how a security program can succeed if you don't have that foundation of visibility to build on. So if that's not a tenet of your program today, I would recommend pulling the emergency brake and asking why that is. Now, ideally, you're going to have some solutions and processes that provide you with some level of visibility today that are already in place. Make sure that's not just point-in-time visibility, but rather a capability you're gathering and analyzing on an ongoing basis to assess your security posture and identify gaps in visibility, and then build from there. For example, if you know what's happening on your end-user endpoints, but you don't have the same visibility on the workloads in your virtual data center, then that's going to be a really good starting point. Same goes for encrypted traffic visibility. Are you doing limited policy-based decryption directly on the perimeter firewall? If so, that's certainly fine. That's a great starting point. But most organizations find that's a pretty heavy load and they just can't decrypt everything they would like to. So make sure you have an understanding of what you can do and what visibility you ideally want to have, and then you can figure out your path from there. Finally, at the end of the day, security is about reducing business risk, as well as the threat scenarios that present risk to the business. Again, understand what the business risk profile is for your organization and what threats your CISO and CIO are most concerned about to the business. And make sure your visibility program supports those objectives. You'll be much more likely to get a successful outcome, not to mention the buy-in that you need from executives. So with that, we're going to give you a look at some specific technology options. So going first, let me hand back once again to JB from Enea. JB.
Thank you, Eric. So my parting advice here is to remember that the traffic classification is a key building block for today's security applications. And it will provide really valuable contextual data for emerging ETI solutions as the amount of clear data in encrypted flows is reduced. So it's really important to find out what kind of classification engine your in-house or third-party solution uses, and whether the roadmap is designed to handle challenges like the TLS 1.3 and encrypted uncheck. If you are using a leading commercial product now, you're probably in good shape because our engine is probably inside. Our engine is embedded, for example, in 3 of the top 4 SD-WAN solutions, 4 of the top 5 SASE solutions, and 3 of top 6 secure web gateways. It's also used by large enterprises for custom solutions. But if you're not sure what kind of engine is under the hood, now I really believe it's a good time to ask. Don, passing to you.
All righty. Thank you, JB. So I wanted to sort of touch back on the earlier slide, right, as I showed that classic example where those legacy products were doing the encrypt, decrypt, encrypt, decrypt, and all the complexity there. Really wanted to introduce our approach, which we call SSL Orchestrator, and why we feel that actually allows you to selectively scale and manage those investments that you've already made in those security products. And really just to jump right into the visual, first of all of the techniques you've heard today are supported in this environment. You know, we're very keen on having an agnostic approach because every one of the customers we talk to today have a mix of security products. And it's really not about the particular vendor, but it's about what service they provide and how they're deployed, whether they're L2, L3. So what we do here is we actually remove the burden. We do the encryption, decryption, we do the key management, and we do the key protection. And we then allow those products that were originally designed to serve that service or that specific security function to do that in the clear. And we do that in a hub and spoke model, which actually allows that traffic then to be steered, for example, to all of your Palos, or maybe to your Junipers, or to your Semantic. And you can do that on a policy basis. For example, let's say you have contractors. You maybe want to run those through every single security chain. You want to decrypt everything. But then you have the executives. And maybe you just want to do the pattern analysis, the machine learning, and just look for abnormalities in that. And because we're hub and spoke, we actually can take that feedback from that security product and actually take further action. And if not, if there's nothing unusual, then we can just pass it on through. So it's really about allowing the investments that many of our customers have made on-prem, but then also anticipating the cloud, being able to actually see some of those pieces move off into the cloud and support the technologies we've talked about today. And we do that through what we call dynamic service chains and doing really a virtual breakout of each of those policies and those technologies to then make sure that we're able to leverage the emerging technologies in a flexible way, but then also be able to update and move those products out in a way that is non-disruptive. And with that, I think we're going to switch it back over to Mike.
Thanks, Don. And so Juniper Networks, is supporting our customers and addressing this challenge of encryption and decryption with a product capability called Encrypted Traffic Insights. This is a capability that resides within our ATP cloud, our cloud, intelligence and analytics service. And so it's just included for customers. And really what it comes down to is it does that aggregation behavioral analysis. It's constantly looking throughout the network in order to identify and to capture those behaviors as the sessions are established, as traffic patterns indicate. And so, even after the connection's established and the keys are exchanged, the fact between two clients, for example, in the lateral scenario, there are going to be kind of clear indicators. And so by leveraging not just the security appliances, but also the intelligence telemetry throughout the infrastructure, we're able to aggregate that and to identify these activities, which further enriches that behavioral insight. And through this, we have a high degree of accuracy. And so, and just a quick example, right? As the session's established and it walks through each of these steps, further refines and builds a more complete kind of fingerprint, which ultimately, in the case of like C2 traffic, we can block the host and technically isolate it, because chances are there's an infection and you got some more work to do beyond just the encrypted scenario here. And so this capability is solving these challenges for customers with a very high degree of efficacy for the known attacks. And what it does is, again, it reduces that load on the entire infrastructure to be able to selectively decrypt and provide operational control over that traffic, so that you've got the right visibility where it's needed in order to really address these challenges at scale. And so with that, Eric, I think I turn it back to you, sir.
Thank you so much, Mike. So I'm gonna have some brief closing remarks, and then we're gonna have a little live Q&A for you. So stay tuned here. So in closing, encryption is a double-edged sword. It's vitally important for both security and privacy, but it is the enemy of visibility, and we cannot ignore that. We need to recognize it and take action to address the need for visibility in our organizations. For those of you that are decrypting traffic actively and passively today, that's great, and I'm glad you made that investment in visibility for your organizations. But you have to recognize that the changes introduced by TLS 1.3, specifically Diffie-Hellman ephemeral and perfect forward secrecy, as well as digital transformation and the growing encrypted traffic volume, these things are all going to necessitate changes for your approach and your architecture. Fortunately, there are some really fascinating and promising alternative approaches that are coming into the marketplace and offer considerable potential. The three that we discussed, cloud-based encryption, SKF, and ETI, Omdia believes will all likely have a place in future visibility-centric network security architectures as we move forward in this decade. Finally, if there's one message to take away, the time to wait and see is over. We know these changes are coming. They're on our doorstep. And adversaries see the opportunity to exploit organizations that are not actively seeking visibility. So now's the time to research these issues in the context of your own organizations and begin work on your plan of action. So that concludes the prepared remarks for our webinar, but we want to hear from you. If you're listening to us live and you have a question for the panel, please submit it now in the question submission area on your screen. So let me try, we'll try to at least do one question for each of our panelists today. So let's start JB, with you. Here's a question. If you have an IDS engine, do you also need a DPI engine?
Well, actually, an IDS is a vertical solution comprised of rule engine and protocol dissectors to create alerts on a suspicious payload or traffic behavior like a DDoS. Some IDS are starting to have more and more complex dissectors to analyze complex protocol metadata, such as the radius or TLS metadata. DPI has been providing these complex metadata since the beginning, but the DPI goes further and specializes in the classification of L7 plus applications, such as the WhatsApp or the BitTorrent of the world. So DPI provided information can be a good complement to an IDS in SIEMs or security analytics solutions.
All right, very good. Thank you, JB. Let's go to our next question. This one, let's send it over to you, Don, from F5 for this one. And you touched on this, I believe, a little bit, but we didn't get a chance to really dig into the differences of orchestrating inbound encrypted traffic versus outbound encrypted traffic. In light of the changing architectural needs that we discussed, what important strategic or technical differences should enterprises keep in mind?
Yeah, no, that's a great question, and for us, inbound is really about protecting those back-end legacy applications. Making sure that you have a strong front door, and as a full proxy, we can ensure that the strongest negotiated ciphers are achieved between the client and the F5 big IP product. And then, depending on the back end, they may be legacy applications that only support TLS 1.1, and making sure that whatever is supported is negotiated. And then with SSL Orchestrator, we can create that service chain, so we can actually simplify the passage or the decision making, again, as a full proxy, where that traffic gets steered into what of those security products are. And again, because they're virtual chains, you can remove or add those to update as needed. The outbound is very interesting, and that tends to be more of a dedicated solution. And that's really where we're acting, again, as you mentioned earlier, as an authoritative man in the middle, where we're caching that information and then making sure that it is going to the right place based on the right policies that you've established. But both of them have different performance characteristics, and both of them, as we've seen, tend to be required in a total solution where one or the other is typically not enough, because as I mentioned, the inbound typically is the attack vector, and then outbound is usually where the exfiltration takes place. So hopefully that helps.
That's great. Thank you, Don. I think we have time to squeeze in one last question. So this one is on one of the emerging approaches, ETI. So Mike, I'll direct this one over to you. And of course, Juniper Networks has long been working not only on network traffic visibility, but also been one of the early leaders in one of those emerging approaches, ETI, as I mentioned, encrypted traffic inference. So as someone who has seen this technology begin to evolve even before your time at Juniper, how much potential do you think ETI has? And are there drawbacks with things like false positives?
It's a great question, Eric. I do think that ETI holds considerable value and capabilities for organizations. We've seen with our customers that our ETI product that does encrypted traffic inference offers considerably higher accuracy than I would have even estimated initially. And what I witness is that 80%, a bit over 80% generally, of all traffic based on known behaviors is effectively blocked without need for decryption. Again, reducing the overhead on the system and really the burden of traffic across the rest of the infrastructure in order to effectively protect against threats. And in particular, I think, and actually you just noted this well done, that it's not just about the inbound tactics and capabilities, because generally speaking, while there are primary communications that come in from the outside via an encryption mechanism, the more nefarious or more challenging threats are those things that land and then ultimately establish that connection on the outbound. So, C2 details or secondary payload actions and so forth. Those are what actors are employing in most of their campaigns. And I think, at this point, it's probably greater than 75 or 78% based on the last data point. So being able to see that and know that that IP address is an active campaign being run by attributions less important, just knowing that it's serving up bad things allows us to very accurately, effectively block or drop that session and the connection. So that the false positive rates that we've witnessed are well less than 1%. And truly in this world with some gates or challenges around that visibility, that's pretty impressive. As a guy who tested technologies for 10 years for much of the world's industries, I've seen an awful lot, and I think that those rates, that performance is very good. There's still room for improvement, of course, but it's one of the best in the industry right now.
Well, you're right, and it's certainly one of a number of fascinating developments in terms of improved visibility alternatives that are coming, as we discussed, and I think it gives us a lot of hope for the future. So, gentlemen, fantastic conversation today. Thank you so much for joining us and being a part of it. So for a few final words, let me hand things back to our host, Alan Tatera. Alan.
Thank you, Eric. And I do also want to thank everyone for participating on our webinar today and for submitting your questions and comments. We do truly appreciate that. I do want to thank Eric for leading our discussion today, and a special thank you to JB, Don, and Mike as well for this very informative discussion. So an archived version of this webinar will be made available shortly. In fact, we'll be sending you an audience link on how you can access that archive. So feel free to come back, view this session again, or even pass it along and share it with your colleagues. Now, you're going to see a survey pop up at the conclusion of our webinar. We'd love to get your feedback, so please take a few moments to complete that. And please continue to follow us on Twitter and LinkedIn for information on future webinars from Omdia, brought to you by Informatech. So again, thank you for joining us, and have a great rest of your day.